Everybody. In this video, we're going to talk about how to convert between decimals and percents and how to teach your students to do that. So to start off, let's just remind ourselves of what a percent is. So a percent is a standardized ratio that has a denominator of 1,000, or sorry, not 1,000, 100. So if you have 20%, that literally means 20 for each 100, um, which we write as 20 over 100. So, when we're converting percents to decimals, we want to use this concept and reinforce this concept when we're teaching it to our students. So, if we have 24%, that means we have 24 for every 100. And when we're thinking about this and we want to write it as a decimal, remember that decimals are also special fractions that have denominators of 10, 100, 1,000, and so forth. And so the fact that we have a fraction that's written with a denominator of 100 means that it should be pretty easy to write this as a decimal. We just think about, okay, well, where is the hundredths place value in the decimal system? So here's our decimal. The first decimal place value is the tenths place, and the second one is the hundredths place. And so we would look at this and say, okay, well, I can't just put 24 in the hundredths place because each place value only gets one digit. So I'm going to put the 4 in the hundredths place and the 2 in the tenths place. Now, why is it okay to put the 2 in the tenths place? The reason for that is because if I have 24 hundredths, I could write this as 20 hundredths plus 4 hundredths, basically just splitting up the place value of the numerator. And when I do that, 20 hundredths can be reduced to 2 tenths. And so 20 hundredths plus 4 hundredths equals 2 tenths plus 4 hundredths. And that's the reason why I can put the 2 in the tenths place. So the decimal version of 24% would be 0.24. Now, what happens if you have a decimal in your percent? So here we have 8.5%, but we can't really just put 8.5 in the hundredths place because then you'd have two decimal places or two decimals in your decimal, which would make no sense. Like, which one's the decimal that's separating the whole numbers from the fractional numbers? So to fix this, what we're going to do is we're going to find an equivalent fraction that does not have a decimal in the numerator. And the way we're going to do this is by multiplying the top and the bottom of the fraction by 10, because this tells us that 8.5% is equal to 85,000. And when I do that, and I expand that out, that gives me 80 thousandths plus 5 thousandths, and 80 thousandths can be reduced to 8 hundredths. And probably when you're doing this with your students, you would want to actually write out the steps for reducing that. But I'll just kind of shorthand it here. And so if I have 8 hundredths and 5 thousandths, I can write that as the decimal 0.085. And the reason why there's a 0 here is because I don't have any tenths, but I do have 8 hundredths and I do have 5 thousandths. And so the way you would write this decimal would be 0.08. Now, when you do several examples of this with your students, they're going to start noticing a pattern that the digits in the percent and the digits in the decimal are the same. And this will always be true. And it's also true that the only difference between the number parts of the percent and the number that you get for the decimal that's equivalent to the percent is their place values. So in this percent, the 2 was in the tens place, and in this one, it's in the tenth place. And the 4 was in the ones, and this 4 is in the thousand, or sorry, the hundred. Same thing here. The 8 was in the ones place, and now it's in the hundredths place. The 5 is in the tenths place, and now it's in the thousandths place. So basically, all of the place values just shifted two place values when we convert from a percent to a decimal. And this is the reason why the shortcut is often taught, that you just move the decimal over twice. It's not actually that the decimal's moving, it's that all of the digits in the place values are shifting to place values, which means that their relationship or their location to the decimal place is moving 2 units. But it's not actually that the decimal place is moving, or the decimal point, excuse me, is moving. But you can teach your students that little shortcut once they recognize the pattern for themselves. But don't just teach that on the first day. Let them go through this process of really understanding the meaning and the connection between percents and decimals, and then you can teach them the shortcut. Or they'll probably invent the shortcut for themselves if you give them enough practice problems, because this isn't a difficult pattern to notice. And if you let your students discover it, they'll remember the process much better. And you won't ever get the question of, wait, which way do I move the decimal? If you teach them the concept, they'll always know which way to move the decimal. And different students will think about it in different ways because they'll conceptually understand it in the way that makes sense to them. So now let's talk about how to convert decimals to percents. So, one of the key features of how our number system works is that each place value is related to the place value on its left by multiplying by 10. So, like if you take the ones place and you multiply by 10, you get to the tens place. If you divide by 10, you move one place value to the right and you're in the tenths place. So, let's say we had a number like 3. If I multiply the number 3 times 100, this basically shifts the place value of the digit 3 two place values to the left. Because multiplying by 100 is the same thing as multiplying by 10 twice. And if I did 3 divided by 1,000, that would be the same thing as dividing 3 by 1,000 three times, which would put me in the thousandths place value, and this would equal 0.003. So, one of the key features of decimals is whenever, or really any number, is when you multiply or divide by a power of 10, you can just shift the place values however many times that power of 10 is multiplied by 10. I don't know if that is the best way to explain that. Like dividing by 1,000 is the same thing as dividing by 10 three times. So you would shift the place value three times. That was what I was trying to say. Um, so this is going to be relevant when we are converting decimals to percents. Because if I look at the decimal 0.5 and I want to write this as a percent, remember a percent is just a special fraction that has a denominator of 100. And the decimal 0.5 is the same thing as 5 tenths because the 5 is in the tenths place. So if I want to get a special fraction that has a denominator of 100, I can just multiply the top and the bottom of this by 10, and this gives me the fraction 50 hundredths, which is equivalent to 0.5, and that is 50% because that's 50 over 100. And then if I wanted to do a decimal like 0.27651, the fraction form of this is considerably more complicated because you're going to have 2 tenths plus 7 hundredths plus 6 thousandths plus 5 ten thousandths plus 1 hundred thousandth. And our goal here is to make it so that all the denominators are 100, which isn't too hard for the first two because if I multiply 2 times 10 and 10 times 10, that tells me that 2 tenths is the same thing as 20 hundredths. And the second one isn't too bad either because it already has a denominator of 100. However, this step might be a little bit confusing for your students. And you could say, okay, well, how can I get from 1,000 to 100 by multiplying or dividing? Well, since 1,000 is bigger than 100, I would have to divide. And if I divide the top and the bottom by 10, then the bottom will now be 100. So I've met my goal of having a fraction that has a denominator of 100. But the question is what is the top? If I do 6 divided by 10, we can think about that as being 6 tenths. And if you want to, you could do this with your students where you write it as 6 tenths as like a teeny little fraction. The notation of that might be a little bit confusing because you've got a fraction within a fraction. Or the other option is that you can remind them that 6 tenths can be written as a decimal, and this would be the decimal 0.6. So you can do it either way. I'm going to use the decimal one, but if your students are really used to thinking about place values as fractions, you may want to go with the fraction notation. So then you can do the same thing for the next one. You can say, well, if I have 10,000 and I want to get to 100, I need to divide by 100 because 100 times 100 is 10,000. And if I do 5 divided by 100, that's 5 hundredths, which I can write as 0.05. So I have 0.05 for every 100. And then you do something similar for the last one, and you get 0.001 over 100. Once all of them have denominators of 100, then you can add them all together, and you would have 27.651 hundredths. And that means that this decimal is equal to the percentage 27.651%. And you can point out that the number that was in the hundredths place is the first whole number. So I wouldn't actually do this whole process with your students very often because it's obviously very long and clunky. But you can point out that whatever number is in the hundredths place is going to be in the ones place in your percentage. And that can help your students kind of understand how those place values are related. So if you had a number like 1.6, in that case, you're going to get a percentage that's bigger than 100%. Because if you write out the place values of this, you would have 1 plus 6/10. If you want to make denominators of 100, because percentages are just special fractions with denominators of 100, you would have the top and the bottom multiplied by 100. And on this one, you'd multiply by 10 over 10. And so this would give you 100 over 100 plus 60 hundredths. That would be the fractional equivalent for 1.6 that has denominators of 100. And this would equal 160 over 100, which is an improper fraction, but it should be because 1.6 is bigger than 1. And that means that this is equal to 160%. So when you're teaching this to your students, I would definitely start with problems like this and do lots and lots and lots of those problems. And then you can move on to maybe teaching them ones like this, where you get bigger, you get numbers that are bigger than 100%, like 200% or 500%. And then you can move on to doing these ones, because I would definitely say this purple one is the hardest because you've got to understand this concept that you can have a decimal in your percent. So that's it for this video. If you have any questions, please let me know.